Dear students, this is Dr. N. Venkatachalapathi, Professor of Mechanical Engineering, Institute of Aeronautical Engineering. So in this session, I am going to discuss on some of the problems related to metal casting process, especially when you wanted to attempting any competitive examinations like GATE, IES, and some other what you call some competitive examinations, central government jobs also. These simple problems is very important to discuss in this session. So I hope after completion of this session, the student can able to understand clearly how do you solve these simple type of problems. Okay, look at. So these are the some important concept related to this pattern allowances, especially before solving the gate problems. I hope you are studied about this pattern allowances. For a metal casting process, mainly all metals will shrink except bismuth. So in that the pattern always it may be shrink. What type of pattern to be, either wooden pattern or metal piece pattern or some what you call ceramic pattern. So different type of material pattern to be used while pouring the molten metal. What will happen? It can able to shrink. So that is why when you wanted to design a pattern, so all these allowances are very very important to provide these allowances. It is just subtraction and addition and some important simple trigonometric techniques to be used to solve this simple variety of problems in the pattern making and pattern design. Okay, so the first and foremost thing is sinkage allowance, that is also called contraction allowance. All metals, when you put the metal, it will shrink. Shrinkage can be, it will give vary material to material, and that shrinkage allowance always it can be the units is mm per mm. So and sometimes mm per meter. So that is 1000. So for example, mm per meter or mm per mm means we can multiply into 1000, and how we can able to with 0.001 size of the contraction and extraction will be taken place. Okay, and that is what in general the shrinkage allowance can be again subdivided into a liquid shrinkage or solid shrinkage. And in general, the liquid shrinkage, it refers to the reduction in volume when the metal changes from liquid state to the solid state for the solidus temperature. So in this account, we have to provide the shrinkage. Either it is in riser which feed the liquid metal to the casting to provide it to the mold. So, and coming to the solid shrinkage means it refers to the reduction in volume which caused to the metal losses the temperature in solid state. So to account the shrinkage allowance is always provided on the pattern. So for example, if you need exactly 100 mm size of the length of the pattern to be required. Okay, so suppose if you use the pattern size is same 100 mm, by pouring the molten metal it will shrink, and this component will become some 98 or 95 like that. Some reduction dimension can be occurred. Suppose when you wanted to achieve exactly 100 mm size, we can add the sinkage elements for that particular which type of material can be used, either mild steel or stainless steel or copper, zinc, any type of material. How much elements should be added? Initially can add. If you provide that 105, then only it will come to exactly 100. If you use that 100 mm, it will come down to 95, so that exact dimension cannot be maintained easily. So that is why always the student need to understand theoretically. If we explain clearly, a shrinkage means we can able to pour the molten metal, it would shrink, and that's why you have to provide some allowance like that. Okay, but while solving the problem, some important allowances need to be remembered. And also in examination point of view, sometimes they may give the allowances, sometimes they may not give the that allowances also. And you have to check which type of material to be used to, how much allowances, either it may be shrinkage or a draft or finishing or machining allowances, and even sometimes negative allowances also to be used, that is called wrapping allowance. Okay, some halo components and all, making a halo positions and all, you can able to use some negative allowances. Some distortion and camber type of allowance also can be used for some uneven shape of the components. This what this is there some important background for solving the any type of problems related to competitive examinations. Okay, now look at, so before going to solve the problems for pattern allowances, so in this table shows clearly the rate of contraction of various metals. So for example, if you take the grey cast iron, GCI, grey cast iron material, when you wanted to consider, so just you can convert either feet you can convert into a some mm or cm, etc. Okay, up to 2 feet you are supposed to provide, the shrinkage allowance will be 0.125. So simply we can consider this is also in mm also 0.125 mm. Okay, so per meter. Okay, again for mm you have to take means divide 0.00125 mm per mm. So like that, whenever if you wanted to have the same type of that units also, you can able to do it. Okay, so even the dimension is 2 feet to 4 feet or 2 mm to 4 feet, this allowances should be provided 0.105. Suppose over more than 4 feet, you can able to take the dimensions for the grey cast iron. Almost all the allowance should be provided 0.083 inch per feet or some per meter, per meter. So like that, these type of dimensions should be collected from the standard textbook, and you need to apply all the, sometimes in the examination for a particular type of material they will give the allowance. So based on that allowance you can calculate the what is the exact dimension of length, and by adding this allowance then you can able to do in a by step format. So not only grey cast iron, if you take the cast steel, the shrinkage allowances should be provided up to 2 feet 0.251. Similarly 2 to 6 feet to 0.191, and over 6 feet it is 0.155 inch per feet, or if it is a 0.155 mm per meter. So this is very important. Okay, it is FES unit. So if you do for MK system or SI system, mm per meter or centimeter per meter or per whatever the units you have to require, you can able to do it. And similarly, if we take the aluminum material, almost all up to 6 feet we can able to provide 0.155. The 4 to 6 feet 0.143, and if it is over 6 feet 0.125. So just you can observe it can vary. Shrinkage always it can vary the material to material and dimension to how much dimension. For example, it is a 2 or 2 mm or 4 mm or more than 4 mm. That size also very important. So by providing these type of allowances, okay, and even the magnesium also up to 4 feet. So the allowances should be added is 0.173, and over the 4 feet is 0.155 mm per meter, or this given the dimension inch per feet. Okay, so these are the some standard rate of contraction of various metals for giving the allowance. So whatever the dimension of the given problem, we should add these allowances so that we can determine the size of the component. Okay, so this is what about the important values to understand, remember for solving the gate problems. Look at it is a one simple exercise. These type of problems they are frequently asked in the gate examination, or not only gate, any competitive examinations. So almost all the students generally their focus will only theoretical part only. Casting means only they'll study what is the pattern, type of pattern, what are the different type of material to be used to, and also what different type of castings, that is sand casting, centrifugal casting, and investment casting. Like the theoretical part they will study. But when you are thinking about the allowances, design part, how do you design a pattern, what are the minimum requirement to design that pattern, what type of material to be used, and which type of allowances, where how much allowances will be added or detected particular field of application. Okay, so look at this exercise is given. The casting shown is to be made in a cast iron. Okay, so they can mention the material type is cast iron. Material type is cast iron. Okay, it is a wooden pattern. So this is also a wooden pattern and cast iron. So almost a wooden pattern can be used limited amount of castings. So when you wanted to produce a more than 1 lakh candle, almost all you can need to have some metal piece pattern. Wooden pattern, if you uses of 50,000, 20,000 more components, some maintenance should be done. Some at the ends and all some cracks and some rings material will be removed due to more usages. Again, some maintenance can be done so that then exact shape and size can be obtained. So here in this problem, assume only shrinkage elements, calculate the dimension of the pattern. So here all the dimensions are inches, or sometimes it is in mm also, if you convert. Okay, so like the only the dimensional need not worry. So here they have given inches, or they will give the in mm. All dimensions are in mm. The people are always should able to focus. Okay, so this casting wooden pattern. Look at, so there will be 14 mm, 18 mm, 8 mm, and 6. This is a 3D diagram, three dimensional diagram. This will convert it into front view. This is the front view. Front view shows how 14 mm, height is 8 mm, and top you can see the dot line. This hollow portion will see in a dot line, so that 6 diameter. The front view. Okay, so almost all if you see the top view means you will have some, this is height 18. Okay, this is 14. This is the hollow shape, 6 diameter. Top view, front view, this is top view. So now how we can suppose to provide the allowances? What type of allowances? Sinkage allowance. So the material type is cast iron. Go to the, this you can see the cast iron, grey cast iron. If they have not mentioned, different type of cast irons also is there. If they didn't mention any cast iron, you can assume that it is a grey cast iron. So grey cast iron up to 2 feet. The dimension is given how much? Look at, the dimension is given 14, 18, 8, 6. So first of all, what is the length? Front you can see this is the length and width. Okay, whatever the material, always when you want to shrink you can see the length and the height only to be considered effectively. And the hollow portion, it will shrink, actual diameter it will expand, or it will be contraction can be occur. So that is also very important. Okay, so here 14 mm is there, 14 inches, 8 inches. So here look at over 4 feet. So over 4 feet, almost all in this problem 8 is there, 14 is there. So all the units will become above 4 feet only, so that we can, that shrinkage allowance should be added 0.083. Shrinkage allowance is 0.083. 0.83 inch per feet. Look at inch per feet. Again, you have to convert into inch per inch. So that conversion also. So for example, this 0.083 mm per meter. Again, if you convert into 1000 means what about? Okay, if you multiply 1000, 0.083 into 1000. How much it is? 8.3. Okay, 8.3. So that this 8.3 mm added to this. Okay, so how much distance? So for example, so this is not 0.83, not 0.83. Okay, so here you can see the how to add these dimensions and all. In this problem, majorly first you have to be drawn in a tabular form. Serial number, this is dimension. So first one 14 inches, second one 8. These two are the very important. So here the allowances, shrinkage allowance. This is you can add 0.83. So by adding the shrinkage allowance 14.030 14.83 mm to be added after applying shrinkage allowance, new dimension. So 8 means here also you can add 0.83. This is 8.83 to be added. Okay. So like that, this is the, by adding the shrinkage allowance, you can keep 18.83. Then this cast iron material will shrink also. It will achieve the exactly 14 mm. If you are not provide this 14.83 mm initially, what will happen? The 14 minus 0.83. So that 7, 1, 13. Okay, so here it can able to produce a 13.17 dimension. It will come down. Okay, so that is why whenever we wanted to apply the shrinkage allowance, we should calculate the allowances accordingly. Okay, so that you need to have some calculation. So you can apply in this case effectively. So similarly, if you take even hollow portion also, 6 means 3, 6 that is inside means you can the hole will be contraction or enlarge. That's what's very important. So 6 means you can add 0.83, 6.83 so that it will become 6. Otherwise that hole become very 6. If you deduct 0.83, that is 5.17 dimension hole can be obtained. So that is why wherever you require the dimension, you can add the shrinkage allowances, original dimension, adding shrinkage allowance, the new dimension will be obtained like this. So this is the way. The problem is very simple, but only thing is you need to remember this important dimensions of the materials, like shrinkage allowance for the grey cast iron over the 4 feet 0.083, for cast iron over the 6 feet 0.155, for aluminium 0.125. This sometimes they may give, or sometimes generally always they may ask ferrous means grey cast iron, or mild steel, or some cast steel, etc. But for non-ferrous metal means aluminum, copper, zinc, magnesium, this type of material can be frequently asked. Okay, even if you see this application can be used also. So what type of application? Sometimes they mention some bullock cart wheels. There is almost all some cast iron can be preferred. Okay, depending upon the application also, you can able to identify which material to be used, what are the allowances to be checked, and where to add these allowances. That is the one important parameter for this thing. So that is why always the shrinkage element should be added. So depending upon the material usages, depending upon the calculation. Okay, so look at, actually I have explained in this with this per meter neatly, but even you can see the how you can able to explain with respect of this inch form, inch for feet, how we can able to perform inch for feet effectively in this type of problem. And the concept is similar for the any dimension. Only thing is you need to understand. Look at, so the solution is the shrinkage elements for the cast iron size up to 2 feet. So size up to 2 feet is 0.125 inch per feet. 0.125, that is the shrinkage elements. 0.125 is the shrinkage elements. Similarly, dimensions for 18 inches. So here dimensions for the 18 inches. So this is the length 18 inches. You are supposed to calculate 18 into 1 is equal to 12 feet. 0.125 divided by 12, which is gives rise to 0.1875. When we round it up, 0.2 inch. Yes or no? And suppose, for example, for the dimensions 14 inch. So if it is a 14 inch, how do you calculate? 14 inch means allowance 8 into 0.125 divided by 12, we will get the 0.09. So that 0.09 can be added 8.09. Okay, and similarly for dimension 6 inch, the allowance will be calculated 6 into 0.125 by 12. Obviously, we will get the 0.0625, approximately 0.07 inch. That can be added. Okay, so that can be added for 6. That is here you have to deduct. For a circular hole means you have to deduct, then only it can able to achieve the exact the 6. Otherwise, if you put 6 means then only it will shrink. If you put 6 means it will come down. What external dimensions you can add, internal dimension we can deduct. 6 means if you do the 5 point this 93 plus 0.03 will get the exactly 6. Okay, so that's why always external dimension will be added shrinkage elements. External dimension add shrinkage allowance. Internal dimension such as 6 whole hollow portion. So this is 8, 14 and 18. So there you have to be deduct or subtract shrinkage allowance. So this is the only important parameter to be remember. Okay. So before applying the allowances, the diagram is 8, 14, 18 and 6. After applying shrinkage allowance, just you can see the same diagram can be modified. The 14 to become by adding allowance 0.15 and the 18.2 and this 8.09. This hollow portion means you have to deduct 6 minus 0.07, 5.93. So if it is a front view means 14.15, 8.9 and the internal diameter is 5.89. This is the way you have to apply the shrinkage allowances for these type of problems. That is why it is very, very important to understand clearly how you will apply the shrinkage allowances for the variety of materials. So for example, if you see the material is the cast iron, you have to add the, instead of 0.125, this 0.251 to be added here, 0.251 divided by 12, and again I have to determine like this. Okay, so that is why here you can convert feet, 12 inches. So 12, how we will convert, that is 0.125 divided by 12, we will get the finally in inch forms. Same unit should be achieved. Okay, so this is the way. Even if you take the other material like magnesium, so up to 4 feet it is what you called 0.173. Here you can multiply 0.173 divided by 12, like that each parameter you can calculate. You can add all the external dimensions, deduct in the internal dimension. This is what about the how do you provide the allowances in the different type of problems. This is the frequently asked for gate examination. Only thing is they will confuse that what type of material, and sometimes allowances will kept internal or external. That is the only two parameter to be need to understand effectively. Okay, so I hope the student can understand clearly about this thing. And similarly, you can see the draft allowance. So obviously the term draft allowance for the various metals, how you can provide the draft allowance. So in general, draft allowance means if the component is a vertical position. Okay, so this is the a component. When you put it in a mold cavity, what will happen? If you open it, this walls will be breaken. That in order to avoid such a thing, this can be done in a some tapered form. Okay, so obviously some tapered shape can be able to provide, so that you can easily lift by this pattern. Okay, the pattern can be, this component can be easily lifted. So if you are not provide the tapered edges, so it is difficult to by lifting, that all mold cavity walls and all will break and out. So that is why. So for this also, what type of material also to be used? Either wood can be used, how much height of the given surface, and what draft angle, that is external angle. Inside, if it is a hollow portion, you should provide some internal draft. Outside means external draft, inside means internal draft. For hollow portion, it should be internal draft to be provided. For example, wood, if you take the wood as a material, the height which is the 1 inch means the external draft will be 3 degrees. External draft to be provided 3 degree. For internal draft also same 3 degree. So for example, 1 to 2 mm of the height is given. This is 1 to 2 mm of height is given. External draft will be 1.5 degree. Internal draft almost all it may be increased to 2.5 degrees. If it is 2 to 4 height, a external draft is 1 degree. Internal draft will be 1.5 degree. And if it is a 4 to, this height can be increases. What will happen? The degrees of the providing the angle should be reduced 0.75, and internal draft is 1 mm. If it is 8 to 32 mm of height, very long height, obviously external draft will be 0.50, internal draft will be 1 degree to be added to, in order to easy withdrawal of the pattern. So suppose if you are not using the wood, if you use the metal or plastic, obviously these are the some important allowances which is collected by the some standard textbook. So which is are very very important. Okay, so that you can able to do this thing. Okay, in a metal or plastic, you can see the 1 mm height, that external draft will be 1.5, internal draft will be 3. If it is a 1 to 2 mm of height, for a metal or plastic, 1 is internal, external is 2 mm, 2 degrees. And if it is a 2 to 4, in external is 0.75 and internal is 1. and it is a 4 to 8 of height of the given surface, and almost the external draft will be 0.5 degree and internal draft will be 1 degree, and 8 to 32.5 of external draft, 0.75 will be the some internal draft. Only thing is, in a hollow portion you can provide the internal draft, external portion you can provide the external draft. This is called the external draft. This is called internal draft. Internal draft means inside it may get some 5 internal draft. Okay, so that is the only, this is called external draft. This is called internal draft to be provided depending upon the material. If you are using the wooden piece material, what are the how much draft angle can be calculated. Okay, and if it is a metal or plastic, in how much type of height is used, where, so obviously as per the this external draft will be almost or less than the internal draft, so that we can easily come out to component easily. Inner also that hollow portion without disturbing the wall faces effectively, so that you can some little bit improving of that draft can be provided. Okay, so this is what about the how you can provide the draft allowances. Yes or no? So this is what you can able to provide, and even this casting process, machining allowances. When you wanted to provide machining allowances, how much? So machining also means after final completion of the coming out of component, you can add some finishing. Finishing either 1 mm or 2 mm based on the material also. That is also very important. Here, how you can provide this machining allowance. You can see this diagram after providing the shrinkage elements. This is the values you can obtain. Yes or no? Suppose if you wanted to add what you call some draft elements and finishing elements, again you have to add some finishing. This is what about for a machining elements for the cast iron size. If it is a 12 inch or 0.18 inch, from 12 inch to 20 inch, 0.2 inch. From the table only I have collected. You can see the for 18 inch allowance 0.2 inch to be taken. For 14 inch allowance 0.2 inch, and for 8 inch allowance is 0.12, and 6 inch is 0.12. So here almost all you can add. You can see 14.15 can be added. 0.2 means 14.2. Okay, so like that you can suppose to add. Here 18.2. Here wherever required, there you can add this allowance, and 8.9. Here you can add some allowance, and here also hollow portion also you can 5.93. Here you can deduction will be taken. All external surfaces we should add, internal can be deducted for 0.12 allowance. This is called 0.2 mm to be added. So this is what about the how you can able to provide the allowances and how to get. So for example, if you calculate all these components, so for example serial number, this is actual dimensions. So by providing shrinkage allowance, by providing machining allowance, by providing draft allowance. So actually if you take the 14 mm and how much you provide, 14.15, 14.15, this is machining allowance 14.2, and similarly if you take 8, 8.09, 8, 8.09 and 8.12, similarly 6, 5.93 and 5.88, 18.2. So this is no need required, 18 or 18.2. here as same 18.2 only, no need required for finishing there. Okay, so like this you can suppose to add only addition subtraction only. If you know this concept, then only any type of problem, any competitive examination can be easily solved. Otherwise it is difficult to solve a simple problem. All these problems to 2 marks, and sometimes they can add before applying the sinkage elements, what will be the diagram. After applying the sinkage elements, what will be the diagram with the dimensions and which type of material to be used. Okay, that is the only thing, that all data will be collected in this type of dimensional parameters. Then you can apply easily in this examination point of view. Okay, I hope all the students can understand clearly. Thank you very much for this session, especially how do you solve the some of the pattern allowances problems, especially for competitive examinations like GATE, IES, and some central government jobs also. Okay, so I hope the students can understand clearly. You may practice some more problems which is almost covered in the previous years in the GATE examinations. And if any difficulty facing, you can bring to the problem to me, so that I can give this some more concept related to solving the competitive examination. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.